What's good, everyone? In this video, we'll be starting another series, and this is specifically around ML model training and inference with containers and Kubernetes. We'll get to the Kubernetes part in later series, but what I wanted to do today was introduce to all of you some kind of fundamental concepts that you should know in ML engineering, and that's the idea of containers and images and using a tool such as Docker to kind of build these out and work with these. And what we'll explore is why we need something like Docker for ML model serving or even training, how it will help you kind of productionize your different ML workloads. And this will give you the foundations, right? When we get to Kubernetes, where we might be working with multiple containers and scaling up containers across multiple nodes and things of that sort. This is a bit more of a self-managed series, right? So this is a little different from using a managed ML service such as Amazon SageMaker. I'll link that series down below as well. Each kind of service has its own use case depending on your ML problem and the kind of technical people that you have on your team. So hopefully this will give some clarity in terms of when you can use EKS, how to set it up really for ML models and things of that sort. But first we want to establish these fundamentals with Docker and containers. And as always, right after I kind of talk through some of these theoretical concepts, we'll get hands-on. I have a sample fast API app that's serving a transformers translation model. We won't really get into the kind of theory or anything behind the data science part of this, but we'll essentially serve that with a running Docker container and see how we can do inference across it. So with that being said, let me hop into my whiteboard as always. And what we'll do is we'll talk about some of these different core concepts. And hopefully you can walk away understanding what a Docker container is, why it's so kind of handy for ML model development. And you'll also see it's very much a industry standard way and tool. So it'll be something really important for you to kind of pick up if you are going into the ML engineering or even traditional engineering world, especially with this whole kind of microservice architectures that we're seeing nowadays. This will give you good foundations in terms of understanding what a container is. So speaking of a container, right, what we can think of this is as our portable unit. This is going to be our central unit as we build across Kubernetes and work with it. And in this portable unit, what I mean is, and think of this as a portable unit of software, in our traditional projects, right, we're going to have a few different pieces to make this project run and to be able to execute it. We have our code. This can be in whatever Python, Java, whatever language you might be working with, right? And then we also have our dependencies. So any kind of things we're installing. So in the purpose of ML, right? Maybe it'll be something like Torch, transformers, and more that we're working with. And then we'll also have kind of our runtime, environment variables, or different configurations that we might be working with. These are all kind of the different parts that we might have, right? Think about a traditional maybe ML serving project that we're working with. These are kind of the different moving parts and pieces that we might have, and maybe you might even have, just adding another one, some serialized model artifacts or configuration as well. Kind of the same as the third bullet, but just trying to give some practical examples since we're coming from the ML space here. All of this, right, is great when you're on your own PC and you're working with it, or let's say you're even on a EC2 instance or something of that sort, right? That you might be working with. All of this is great, but how do we really kind of share this with a team? Or let's say this is a solution that we've built that we want to open source and that we want to kind of allow for people to pull down and then also work with, maybe extend and build their own stuff on top of it, right? This is very, very difficult when it's all standalone, and we really needed a way to be able to kind of package this, isolate, and port everything that we're talking about here in a very easy way. And this is especially true in data science because a lot of us come from, or at least I did when I was first learning data science, from this Jupyter Notebook world. I'd have just a massive pip install with all my dependencies kind of at the top of the notebook. Then I'd have random training code in a loop, something of that sort, running across whatever data I'm working with. And then I'd load the model within that own environment, right? This is really unshareable and they're kind of useless. Not useless, they're great education learning tools. They're useless when trying to productionize. Useless might be a harsh word there, but what I'm trying to say is when we're trying to productionize this in a bigger application, it's really hard to integrate a Jupyter notebook or something of that sort. You can't really go this route where you just have everything living in its own space. And that's where data scientists and ML engineers, right? A big part of the handoff in some of these tech companies is taking that data science work and actually putting it together in a logical software unit, right, that can actually be shared and worked upon. And that's where the idea of a container came, right? Where we need an easy way to be able to ship the code that we're working with and things of that sort. And we need to be able to share it with other developers, maybe not even just on our team, but if we're exposing this, right? So with a container, we have a very isolated and portable unit of software that we can work with, where we can configure the environment and we can basically set it up in a way that anyone who has Docker installed, basically, which is our kind of container tool or software that we're using. So Docker is a container-based software to help you work with different, they're called Docker containers and images, which we'll explore in a second. But the idea is with this container, we have an environment that anyone can pull down. So anyone can pull this environment down, work on it, extend it, and especially within teams, right? Let's say you're working across different teams with this Docker container, you can easily share this code across. And even if they're working in a different environment, right? Let's say they have a different version of Python or something installed or whatever, it becomes very, very easy to understand the environment that you need and that you're working with here because it's all packaged into this container basically. And now that begs the question sometimes, right? Or a question I had was the comparison between these three different things. What's a container versus a VM versus a virtual environment? Excuse me there. But a virtual environment, this is a Python concept, right? This is the easiest one to distinguish, so I'll talk of it really quickly. This is great if you're locally prototyping. You have a virtual environment and you can isolate your dependencies in there. But sharing this to other developers or teams of developers is difficult. You're still constrained in a sense where this is just limited to you. And this is not really something that you can share with a virtual environment. Now, a VM, right, versus a container, this is probably the harder thing to distinguish. So bear with me for a second. And if you don't understand it perfectly, apologies there. The video I've linked down below will also help explain it a little more. But a container versus a VM, right? With a VM, what we're looking at, and I could probably take out this versus right there. But with the VM, what we're looking at, right, is each virtual machine has its own OS kernel. And this is a hypervisor that is dictating all of this. And what the hypervisor does is, right, let's say, for example, you have a 30 CPU machine. What we'll hypothetically do is it will give 10 CPUs to one VM. It'll give another 10 CPUs maybe to, let's say, VM2, and then another 10 CPUs to VM3. So the isolation is at the OS level itself. And essentially what that hypervisor is doing is it's basically almost tricking, I guess, the VM into thinking each one has its own OS kernel, and as a result, it has its own dedicated hardware resources that are allocated. So it's basically sharding across the hardware resources in essence, and this is what a virtual machine itself would be. So you can think of the kind of splitting or sharding happening at the OS level itself. Now with the container, right, this is going to happen at the process level. All containers will still share their host's hardware resources, and they don't have their own OS kernel or anything of that sort. So if you have multiple containers running, for example, on your local machine, like we might right now, they're all sharing your host hardware resources basically. They're not allocating a certain amount of CPUs to each container, things of that sort. But we will see with Kubernetes, a tool like that where you have multiple nodes or a cluster of nodes, you can kind of scale up containers across things known as pods. That's a whole other concept that we'll talk about. But with a container, right, we have you can think of this as lightweight, because we are not talking about having our own sets of resources, our own kind of OS kernel that we're working with. So containers are much more lightweight and easily kind of shareable and downloadable essentially. So that's the main difference between a container and a VM in terms of how are we essentially partitioning our resources basically, right? So the VM, think of it at the OS level itself, whereas with the container, we're just sharing the host's hardware resources basically that we're working with. And containers, since they're so lightweight, they become easy to scale using different kind of cluster-based tools such as Kubernetes, where you can also manipulate and play with multiple different containers. So that in essence is the difference. And the main takeaway here is not only since they're lightweight, but since they're so portable as a result, right? We can share this easily across different teams and even out open source, as I was saying. And you'll see public examples of this. You'll see, for example, we talked about things such as VLM and TRTLM before, these open source solutions that have been shared by places like NVIDIA, and I don't know who VLM's from, but essentially these are all present at the end of the day as Docker files. You can basically extend these Docker files that present this software and basically kind of build on top of it because the environment comes pre-made for you basically, and anyone who has Docker installed can basically pull down that lightweight image and get started to work there. So that's where it's become much of an industry standard, and Docker's kind of the leading container tool that's out there. I've just learned that it's what's used most heavily. That's why it's become such an industry standard in terms of being able to ship, port, and kind of like share code basically, and any software that you're working with. So, with that being said, right, let's maybe talk specifically about why Docker for ML. And for this, right, I was kind of alluding to it earlier. There's a dependencies nightmare in ML. There's so many different open source frameworks, which are all great standalone, right? But when we try mixing and baking all of these, especially when we get into different Python versions, such as like 3.10, I think 3.9 is getting deprecated, but going on, basically, you get the point there. Matching all of these different ones to each other in a workable environment is absolute hell, as we know, right? In certain cases. And when we have a container, we'll see a Docker file, right? We clearly kind of define out what we need to basically run this piece of software. You'll see the real value prop of a Docker container, and especially for ML development, which is so Python heavy and dependent on so many different packages. It becomes very, very easy to kind of have a container that you can easily build and then ship to whoever else might need it. And with that being said, the last thing I want to talk about, right, before we talk about, or sorry, get hands on, is maybe some Docker terminology. I know this might be a little overwhelming for whoever's new, but just to give some terminology here, we have a Docker file. And you can think of this Docker file as the set of instructions. So in this Docker file, we might be doing things such as our pip install. We might be pointing towards which Python files or servers to execute. We might make a working directory with our different files. This is basically where we're giving the instructions in terms of how do we bake our image, kind of what needs to happen to build our Docker image. And that Docker image, right, you can think of almost, so this is what you build up basically. And this can take some time because you can imagine if you're installing different dependencies or things of that sort, whatever amount of time you can imagine that's what's happening here. You can build this and you can think of this as a bit of a static snapshot in terms of everything that you're basically sharing. And then that Docker image, right? An instance of that is a Docker container. Instance of the image. And with this Docker container, this is what we'll be running to kind of serve our ML model. And this is what we can hit and invoke depending on, and you'll hit it or invoke it depending on whichever things you're exposing within that Docker file. So for example, we might expose a certain port for inference. If we remember within SageMaker, there are certain ports that had to be exposed, right? When we were bringing our own container to kind of be able to infer or invoke it properly. So we'll see all of that. But in essence, right, these are the three main things that you just want to have an idea of before we get started with Docker. Like I said, this is just the software to work with containers and images and many of the core concepts we talked about. And a container, right, as we talked about, is basically that portable unit of software. You can think of it as that. And in this series, what we'll do is we'll scale these containers across multiple nodes or instances using something like Kubernetes. So this is our fundamental piece or unit that we're going to be working with. And with that being said, right, let's maybe get hands-on. If a lot of this hasn't made sense yet, we can talk through basically really quickly in terms of how our sample will look. Let me put my pen away right there. And let me pull up our code. So for the code, by the way, or for installing Docker before any of that, you can go to the Docker URL, and I've shared that down below, and you'll see that you can download it depending on the machine that you're working with. I definitely need to upgrade my Mac at this point, but that was my option, the Intel chip-based one. And then for the code itself, I've created a repo called EKSML, which will have all these different samples. So, and I'll update that with the videos and all the different things we're working with. But this first directory here will basically contain the different things that we're going to be using here today. So with that being said, right, let's go into Cursor, our handy friend. I'm still using that as my main AI coding assistant. I know everyone has a preference nowadays, but let's get right into it, right? So first, let's just imagine our code. What is our code that we're going to be working with in terms of our model serving logic? I'm going to use FastAPI in conjunction with something known as Unicorn. This is just our server basically in terms of actually being able to handle the HTTP requests that are coming in. What I'm going to do with FastAPI, right, is in this, I'm going to first load my model. I'm going to have this translator. It's going to convert text from English to French. This is the model that it's going to be using. This is a CPU-based model, so you should be able to run this locally in your environment that you're working with. Here, I then, from transformers import pipeline, that's essentially what happened there. I've structured my input quickly using Pydantic. This is the data structure for the input. You can adjust this up for more complicated use cases, as maybe if you have some sort of image data or anything that you're working with. And I'm going to take the dash translate path. This is going to be key, right? Because when we invoke this model basically, or the path that we're exposing this on, we need to make sure that we include this in that URL essentially. Here then, right, very simple model inference. Obviously, this can get more complicated. You might have multiple files, like utility files or anything that you're working with there. But here I just take that, I run my model inference there, I structured this output text, and that's what I'm going to be returning. Very, very simple. And the other thing that I need for this to all work is basically my dependencies. So FastAPI, Unicorn, like I said, this is going to be the conjunction for our serving logic here, or our server here, and then Transformers and Torch for basically our actual model working. Now, like I said, right, we need the blueprint. We need the blueprint for the image, and from that image, we'll make an instance of it, right, which is our running container. So if we come here to this Docker file, you'll see that there's multiple pre-made kind of Docker images that you can extend. And you can see this in the public Docker desktop repository here too. These are my own images, but if you want to explore different images, right, that might already be out there that you can kind of use as a base, so this is already a configured environment, you can already see the benefit here. We're saying from Python 3.11, so this is built already for a Python 3.11 environment. So you can see kind of the simplicity in terms of porting things over there, right? So we can take a look at the different images that are available here. Just when you download Docker Desktop, you'll see that. Then you can also see the different images that you've built out over time. And we'll get into this in a quick second. But here I'm going to use that as my base image. That's going to be my configured environment from that. And then I'm going to set up a few different system dependencies. You can ignore that. But here I'm setting up a working directory. So you can imagine, think of it almost as the file system that you're working in. In this app directory is where we're going to copy over our requirements.txt and our app.py. Like I said, if you have a bunch of different kind of Python files, you can bring whatever project size, anything that you're working with here, right, onto this app right here. And I'm also going to then install my requirements.txt, and I did torch CPU here as well as an extra index right there. And then, like I said, you're also going to expose the port that you want, right? So here I've done 80, just as a standard here. And then I've given the kind of basically command, CMD right here, this command right here, to start this web server that's serving our ML model, basically. This is basically, once again, like I said, a blueprint for how everything needs to be executed for this project. So let's say when we share over all of our code and things of that sort, right, this Docker file will point at the necessary dependencies we have to install. It will copy over our serving code, things of that sort, right? It will expose the ports necessary for inference that we're working with. And this can change, right, depending on what tool or service you're using. SageMaker, for example, expects a certain port to be exposed for inference. I keep bringing up SageMaker because we've worked with that in the past in this channel, but you want to check the documentation, right, for whatever service you might be working with. What is the port that I need to expose to be able to work with kind of the service that I'm working with here? Because normally different ones will have different contracts in terms of where inference can happen. That's just something to keep in mind as you work with different technologies. And then you can also give any commands, right, in terms of how do we actually execute the code here to kind of have the functionality that we want or that we need here. So that's what I'm doing here in terms of starting the web server. That then is my Docker file. And now that we have this Docker file, right, like I said, this is our blueprint. What we can do now is we can build our image from this. And if we go over into the readme.md here, you'll see that we have a build command, and you'll get familiar, right, as you play with Docker more and more. There's these different kind of commands that you can use with Docker. And I'll attach also kind of utilities in terms of what are the different CLI commands you can work with. But here I'm just going to give it a name, and I'm going to tag it in terms of whatever I'm working with here. So we come here, we build this out. I've already built it out, and we'll see that that's not in that directory. Okay, right there. Let's just run that same command now. If we build it, you'll see that I've already kind of done this before, so that's cached, so it won't take as long. But if you build it the first time, this might take a few minutes, because once again, depending on when you're installing all these different dependencies or anything that you're working with, it might take some time there. So fully dependent on your dependencies, what you're working with there. You can also see the different Docker images you have by running a Docker images command here, and you can see what you built, and you'll see this is our Docker image, our snapshot basically that we've built out. Now this alone is not going to do anything. We also have to run or start this container basically. And for that, what I'll do quickly here is, once again, I'm exposing the port. There's going to be the host port and the target port. The port we've exposed is 80, right, within our Docker file. So that's our target port that we're going to specify there. I'm then going to start this Docker container with this Docker run command. See right here, we can do a Docker PS to see which containers are already running. And we can see that this image, once again, that we specified right there, this container is up and running here basically. And we can see the ports that we've exposed it on. And now what I've done here, right, is we have this client.py. And with this client.py, you can also do this through curl. We'll essentially kind of hit the path that we were talking about. So in our Fast API app, we'll expose that invocation path that we're working with. And using the request Python library, or you can use curl too, we'll basically pass in this payload and get a response back. So if I run Python 3, client.py right here, you'll see that there's a translation right there basically. And you can stop this container after. I'll link the command down below as well. But in essence, we can keep running this. And if you want to do something like load testing or things of that sort, you can do it by hitting this path basically, or just using this script right here in terms of what you're working with. So that at a high level, right, is what I mainly wanted to cover. We can see here that we were very simply able to kind of containerize this. And now if I ever wanted to share it with someone, it's very easy for me to port and share, be it in my own team or even externally, especially externally, right? If you think of different companies, right, that are building huge sets of software, these open source ML model servers that we're talking about, it's very, very handy to kind of have that base Docker image that we're working with to kind of extend and build on that project. So it's a real industry standard, right, in terms of kind of sharing and porting over code. And now the next steps, right, that we'll get into, right, is now that we know what a container is, we know this is our unit, that's our building block. What we can then do from here is we can take this and see how can we scale. So this on just my local machine is not going to be very effective. Let's say if I'm receiving thousands of transactions, there's a limit on the hardware resources. Now it would be super, super handy to have a tool or service where there's container orchestration across multiple different nodes or instances. And that's where something like Amazon EKS comes, which is their managed version of Kubernetes, where we'll have multiple different nodes that you can maybe scale replicas or copies of your container kind of across. And there's official terminology for all of this as well. But in essence, right, this building block that we have here can be manipulated and scaled in very powerful ways to really kind of scale up your ML inference. And you can imagine this, right? You can imagine having this rather than just your local PC across multiple nodes in a managed way, almost with EKS. There's obviously the self-managed aspect where you still are defining the hardware and things of that sort. But if you have a managed kind of cluster tool like that, you can make this very, very powerful, especially as you're scaling your inference and things of that sort. And like I said, this compared to a fully managed service like SageMaker, it's a little different. There's different skill sets and things that you need to learn, but both of them have their own use cases. So my goal with this series, right, I've kind of covered the SageMaker side of things and will continue to do that. You get a bit of a hint into a bit of the self-managed world where you do have to work with the Docker container yourself. Whereas with SageMaker, there was those managed Docker images, right, for most use cases. You'll kind of see and cross-match when to use what, depending on your team's technical skill set, what comforts you have, obviously what other constraints in terms of performance or SLAs that you're looking for. But yeah, thank you as always for watching. I think that's mainly what I had for today. Hope this was a useful introduction to Docker, to containers to ML model serving with it. There will be much more in this series. And as always, if you have any questions or feedback, leave it down below in the comments and I'll do my best to get to it. Thank you, and I will talk to you all very shortly.